Mr. Bowman here. Today's learning objective is in green, and we are learning to use probability trees to determine the probability of combined events. Probability trees, they're not new to us anymore. We learned about them in the last video, but this idea of how they relate to conditional events is new to us. Just to recap, so we got independent events is what we focused on in the last probability tree video, and they are events where the probabilities are not impacted by each other. So probabilities are not impacted by each other. So an example of that is the probability of me making my shot if I'm playing a game of basketball. That's probably not going to be impacted by the probability that my friend got an A in his maths test. So for some reason, that test shouldn't impact the probability of me getting my basketball shot. So there's no relationship between those. But conditional events, and that's what we're going to focus on today. So conditional events, that is when the probability will be impacted by another event. Probability will be impacted by another event. So for example, that basketball game we're talking about, maybe we're talking about my maths test. So maybe I completely failed my maths test and I'm really sad, really down about it. That's probably going to get into my head and impact my basketball game. But if I got a really good grade, maybe I'm more confident, maybe I'm more likely to make that shot. So the idea of that test being my test might actually impact how I perform. So the probability is going to change based on something that happens beforehand. And I've got an example here, the bag of marbles, that is a conditional event. So I've been asked to draw 2 marbles from this bag. And this is conditional because let's say I draw this blue marble first. That means that marble's no longer in the bag, which means you can see there's less blue marbles to pick and a smaller total of marbles to pick. And if you think of F over T, the favorable outcomes have declined, the total outcomes declined, and your probability of getting a blue marble in the future is also going to decline. So that first marble is going to impact the probability of the next marble. That makes it a conditional event. And we need to think about how the probabilities change. So let's have a look. So firstly, we're going to draw that, and we're going to start off with our 3 possible outcomes. So you could get a blue marble, a red marble, or a green marble. And if you draw these, the same could happen. Blue, red, green, blue, red, green, and then blue, red, green. So a very cozy probability tree, but there we go. Just realized I've done a mistake there, so that goes to there. There we are. So there's all the different combinations we can get. Let's have a look at the probability of a blue marble. There's 6 blue marbles in total. That there would be 6 out of how many there are in total. So we've got 1, 2, 3, 4, 5, 6 blue, 1, 2, 3, 4, 5, 6, 7, 8, 9 red, 1, 2, 3, 4, 5 green. So that makes 20 marbles in total. So there is going to be 6 out of 20. Red will be 9 out of 20, and green would be 5 out of 20. So those are our first probabilities, and that marble drawn is now going to impact what's happening next. So let's say we draw this blue marble. There's 5 blue marbles left out of 19. So the probability is now 5 out of 19, and this is what a conditional event should look like. That probability of a blue has changed. What I might do, just to make it easier, I might write the probabilities at the end of the tree there, just so we can see them. So red, there's still 9 red out of 19. And green, there's 5 out of 19. So those ones haven't changed, just the blue number 5 has changed. We're now going to have a look, while we draw a red marble to start off with, what's happening. There are 6 blue marbles out of the 19 total. So the number of blue stays at 6. but the number in total has dropped to 19 because I've taken a red one out. Red ones, there's one red one less, so 8. The 9 has fallen to 8, and that's out of 19 because there's one less in total. And green, unimpacted, so there's 5 green out of the 19. And then last section, well, if you drew a green marble, how's that going to change the probability? So we've got blue, there is 6 in total out of 19. Red, we didn't draw any of the red ones, so there's still 9 out of the 19. And green, there is 4 out of the 19. So we can see all the probabilities come up. We're then just going to list our outcomes. So this here is blue and blue, blue and red, red and green, red and blue, 2 reds here, red and green, blue and green, green and red, and then green and green. I'm not going to find the probability for each of these branches. We'll just look at the relevant ones based on our questions later on. Okay, there's our probability tree. A bit messy, takes quite a big or long amount of time to get the tree right. But let's have a look at our questions now. Determine the probability of getting 1 blue and 1 red. So the probability of 1 blue and 1 red. So have a look at your branches. Which outcomes would relate to blue and red? So this one here would be a tick, and this one here would be a tick. So there's 2 outcomes. That one there is 6 over 20 times 9 over 19. And this one here, 9 over 20 times 6 over 19. That top part there becomes 54 out of 380, and so does that other one, 54 out of 380. So when we add those two together, so 54 over 380 plus 54 over 380, it gets us to 108 over 380, and we can get our calculator to find out the probability in a decimal. 108 divided by 380, that gets me to 0.2842. And that there had a 4DP rounding. So we've got our first one. This one's a bit messier because we're dealing with fractions. And the last question, what is the probability of getting 2 marbles of the same color? So we're trying to find the probability that they are the same. And maybe I'll change pen color for this one, just so we can see the difference. We'll get into the pink pen. The same colors would be the blue, blue, the red, red, and the green, green. So we've got 6 over 20 times 5 over 19. And that there is going to be 30 over 380. Red, red is 9 over 20 times 8 over 19. That there is 72 over 380. And the last one, green, green, is 5 over 20 times 4 over 19. Just a reminder, I'm working backwards on my tree. That there is 20 over 380. So I've got the 3 probabilities. I'm going to add them all up. So that's 30 over 380 plus 72 over 380 plus 20 over 380. And I add them all together. That's going to get me to 122 over 380. And finally, I get to my decimal. So on my calculator, 122 divided by 380. That gets me to 0.3211. 0.3211, and it made a 4DP rounding. So guys, hopefully you can see how these conditional events change our probability trees. Thanks so much for watching, guys. Now let's get into heaps of practice.